Hello everyone, this is the Brits from Math Dr. B coming at you with another tutorial. This time the tutorial is on ellipses. Ellipses are a type of conic section. Don't want to scare you. So it's like something like a parabola, which is not that scary. I want to give you a heads up on this video. There's a lot of stuff on the board. My goal is just to kind of clear things up and some of the common confusions. I feel the vocabulary is what holds back most students from understanding conic sections. For example, for an ellipse, you'd actually derive some pretty crazy looking equations from the equation of a circle. I'm not going to do that in this video. What I'd like to do is I'd like to give you a typical question you might be asked in an advanced algebra course or maybe even astronomy or different types of subjects that look at these types of geometric figures. Here's a question. They give you a major axis of an ellipse. It's vertical and its length is 18. Right off the top, major. What do they mean by major? Well, if you think of major in minor league, major means the bigger one. Minor would be the smaller one. Axis. What do you think of when you think of axis? Well, the easy days are x-axis is horizontal, y-axis is vertical. The length of the minor axis, well, if they say the major is vertical, what do you think the minor is going to be? Yeah, it's going to be horizontal. So they give you these lengths. They tell you a center. So that's one thing. Let's look at a circle. A circle, when you think of a circle, it has a center. It also has a radius. Now, a point from the center to any point on the circle has the same length or the same radius. That's why you get a perfectly beautiful circle. Well, an ellipse has kind of two radiuses or radii. One will be for what they call the major axis. In this case, the major axis is more longer, and then it has a radius for how wide it is. So I'll show you two possibilities: a tall and thin ellipse or a short and wide ellipse. Not a circle, but kind of like an oval shape. Sometimes people say it. This question asked you to find an equation in standard form. So I want to talk to you about some things you could read. There's so many different pictures and diagrams. Stick with me and I think it'll come together. I wrote some words here that hopefully you can just pause the video and kind of write down the notes and look at it. But the words are, when you're thinking of ellipse, they usually talk about things like radii. They also say these horrible, terrifying words, semi-major axis. So what do you think of the word semi? Don't think of truck and you want to get hit by it when you do math. Haha. But semi, like a semicircle, would mean half a circle. So when they say a semi-major axis, that would be half the axis. And to be honest, it really means the radii in that particular direction. So what is the complication of having two radii or two radiuses? Well, it comes up with you have two different looks for the equation of an ellipse. So this is kind of frustrating, but just handle the heat. This is an equation, a standard form of an equation of an ellipse when it's tall and thin, and this is the form of an equation when it's short and wide. So that's what you got to look at. Is it taller or is it wider? And these are the equations that go with it. Now I want to talk to you about a couple key points. One is you have an x term and a y term. They're both squared, as you can see. Both of them have an xy term. Now the x term, which means it has an x, the thing below it or the radius that goes with it will always be a horizontal radius. So that should make you feel comfortable. When you think of x, think of x-axis and horizontal. When you think of y, you always think of vertical. Likewise, the radius that goes with the y term will always be the vertical axis. So that's kind of a nice comfort thing that you can feel good about. Another thing I want you to know, the larger denominator will always go with a squared. So that's kind of a little trick. Think about why that's true, but I want you to know the larger denominator in these formulas always is going to be your a squared term. So if you looked at both of these formulas, what are some commonalities? They're both equal to 1. That comes from the derivation, which we're not doing in this video. They both have parentheses y minus k squared. They both have x minus h squared with parentheses. That is The h and k go from the center of the ellipse, and similar notation for the center of a circle with h, comma, k. Now, let's look at these two formulas and see if we can make some sense of this. Well, they say the major axis is vertical. Well, which one? Major means it's the longer one, so we're looking at tall and thin. They also refer to the semi as the radius. Well, they don't give you the semi-axis, they give you the length of the entire axis. So what's going to be the radius? It's going to be half of this. So the radius, also known as your A value, is going to be 9. Likewise, the length of the minor axis, which is going to be 12, half of that would give you the radius of the minor axis, which is 6. And that's going to be my B value. I wanted to draw the picture, even though most of the questions won't ask you for the picture, just so you see it. Notice I have the radius of the major axis is 9. If I went all the way down, it would be 18. So the length of the major axis would be 18. The length of the minor axis would be 12. It's horizontal. I put the center. Now I did something tricky here. Pay attention, it might help you with some application questions. You're allowed to move your x and y axis wherever you want as an orientation. It's meant to be a reference for you to do questions. I put the center, -1, 2 at my origin. And then I just went 6 to the left, 6 to the right, and I came up with these 2 points. But this distance right here that I'm doing, that would be the minor axis, length of 12. This top distance is the length of 18. We know A is 9, like I said before. We know B is 6. We go to our equation for tall and thin. And I put a couple notes here. Notice always the radius along the major axis is your A value. Major axis is vertical, so A is half of 18, 9. Plug it in where you see A squared. Let's look at the B. The B went with the x term this time, so B is 6. This is horizontal, that length is 6. I plug it in where I see a B. Notice I plug in the K and H from the center. One of the tricks I see a lot of students mess up is what happens when you have a minus minus. Gives you a plus. The answer is simply y minus 2 squared over 81 plus x plus 1 squared over 36 equals 1. That would be the answer, but more importantly, do you see how the pieces come together? Do you know your A versus a B? Do you know your major axis versus a minor axis? Major's bigger, minor's smaller. You can have 2 types of ellipses, tall and thin, or narrow and wide. Keep checking out for more videos. I'll probably do a couple of applications with this one little point that I think you need to pay attention to. I can choose how I move my x and y axes to make my math easier. So this is the bridge for math helping you out. Take care and keep crushing.